For the next problem, we have a Ferris wheel that's constructed such that a person gets on the wheel at its lowest point, 5 feet above the ground. The highest point on the path is 120 feet above the ground, and the amount of time it takes to complete one full rotation is 8 minutes. A person's vertical position y, so how high they are off the ground, can be modeled as a function of time in minutes, since they boarded t, by the equation f of t equals a cosine bt plus d. We're going to graph the person's vertical position for one cycle and then find f of t. And I'm actually going to change this on the video to 2 cycles just so we can practice one of those. So first off, interesting piece of information is that we get on at the bottom. So we need to be down at 5 and go up to 120. It looks like going by tens will work. There, so we can fit the graph. So I'm getting on at the bottom. My period is 8, right? We're going to be full rotation in 8. So, and I want to graph 2 cycles. So this would go out to 16, but I'm starting with the 8. I've split up into my quarter points. So I'm starting at the bottom. I will end at the bottom. In the middle, I'm going to be up at 120. And this makes me feel like I need to find midline now to know where I'm going to be my quarter points. So I'm going to average my max and min. And I get 62.5. So at my quarter points, I'm going to be at 62.5. So graphing my first cycle, and then I'm just going to repeat this again. So I'll be back down here at 16, up at the top at 12, and quarter points at 10 and 14. So here is my second cycle. So looking at this, we already have our midline, which is going to be our D value. Our A value is the difference between the max and the midline, which comes out to 57.5. And my period is 8 minutes for the one cycle. So my B value is 2 pi over 8, which is pi over 4. So writing this out, big piece of information that's different here is we have a negative cosine curve because we start at the bottom. So we need to do negative 57.5 cosine pi over 4t. Call this f of t. And then we have to add on our midline. So amplitude of 57.5, I think I might have said midline there. Amplitude of 57.5, negative because we start at the bottom, B value, and midline. So I'm going to look at a graph of this. So I have negative 57.5 cosine of pi over 4x plus 62.5. Window here, I've got 0. I'm going to look at both cycles, so 0 to 16. My hash marks are by 2s, and I need 0 to 120, and I'll leave it at 10, that's fine. So there's my 2 cycles. If I had forgotten the negative sign, and I checked it, I would see that I was backwards. I was getting on at the top of the Ferris wheel, so that's why graphing it is good to check. The last couple of questions, the next one says, we just have a verbal description and we have to answer something. It says the possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum number of hours of daylight is 9 hours and the maximum is 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the amplitude? So if the min is 9 and the max is 15, the midline averaging those would be 12, which means the amplitude is 3. Next one, it says the voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts, and there are 60 cycles every second. So this is kind of a physics topic that we're not going to get too much into, but it is modeled with a sine equation. Now, this 60 cycles every second. That's not a period, okay? That's how many cycles happen per unit of time. So looking at this, my frequency is actually 60, which means my period is 1/60. So my B value is going to be 2 pi over 1/60, or 2 pi times 60 over 1. So this is going to be 120 pi for my B value. So this is the equation I want. So it's a little different to start from frequency, but I wanted you to see one of those.